Have you ever wondered how big or hot the sun is? Well, let's delve into the fascinating world of our solar system's most massive resident. The sun is the largest object in our solar system, with an equator circumference of over 4 million kilometers and a radius of about 695,700 kilometers. This gigantic star makes up a staggering 99.86% of the entire solar system's mass. To put that into perspective, it could contain roughly 1.3 million Earths. Despite its colossal size in our perspective, the sun is actually an average-sized star. Some stars in the universe are as little as a tenth of its size, while others are more than 700 times larger. However, the sun's massive size and strong gravity make it a near-perfect sphere. So, what is the sun made of? Primarily, it's a ball of gas and plasma, with hydrogen making up about 91% of its composition. Under intense heat and gravitational force, this hydrogen is fused into helium during the process of nuclear fusion. But the sun isn't only hydrogen and helium. Scientists have detected at least 65 other elements in the star's composition. The most abundant of these include oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur. These elements, though in much smaller quantities compared to hydrogen and helium, play a crucial role in various processes happening within the sun. The sun's composition and its intense heat create a phenomenon known as solar wind. This occurs when the plasma, heated to extreme temperatures, contains so much energy that the charged particles can escape the star's gravity and blow out into space. When this solar wind hits Earth's atmosphere under certain conditions, it can cause auroras, like the Northern Lights, a spectacle of nature that has fascinated humans for centuries. So our sun, a near-perfect sphere due to its massive gravity, is an average-sized star that holds most of the mass of our solar system and is composed mainly of hydrogen and helium. It's a fiery ball of gas and plasma, a source of light and life, and a marvel of the cosmos. Now that we know the size and composition of the sun, what about its temperature and rotation? The sun's core is a blazing furnace with temperatures reaching a staggering 15 million degrees Celsius. It's here in this scorching heart that the magic of thermonuclear fusion takes place. Hydrogen atoms merge to form helium, resulting in the release of an immense amount of energy. This energy manifests as heat and light, powering the sun and providing the Earth with the warmth and illumination necessary for life. From this fiery core, the energy embarks on a million-year journey to the sun's outer layer, the convective zone. By the time it arrives, the temperature has cooled considerably, to around 2 million degrees Celsius. Further travel brings the energy to the sun's surface, where the temperature has dropped to a comparatively cooler 5,973 degrees Celsius. That's still hot enough to boil diamonds. Interestingly, beyond the surface in the sun's atmosphere or corona, the temperature actually increases again, reaching roughly 2 million degrees Celsius. This surprising temperature hike remains one of the greatest mysteries surrounding our star. Now let's talk about rotation. Although the sun isn't solid like Earth, it does rotate. The plasma on its surface swirls around, taking an average of 27 Earth days to complete a full rotation. However, not all parts of the sun move at the same speed. The equatorial regions take a mere 24 days to rotate, while the polar regions take more than 30. Sunspots are a fascinating feature of the sun's rotation. These are cooler areas on the surface of the sun, appearing darker against the surrounding warmer plasma. With diameters reaching up to 50,000 kilometers, these spots are believed to be caused by interactions with strong regions of the sun's magnetic field, slightly reducing the radiation from the core and cooling the surface. With temperatures hot enough to boil diamonds and a rotation that varies across its surface, our sun is not only the center of our solar system but also a celestial body of complex and fascinating dynamics. And so we've journeyed from the scorching temperatures of the sun's core to its complex and powerful magnetic field, unraveling the mysteries of the solar wind and the stunning aurora borealis it creates. We've navigated the sun's ever-changing magnetic field, which flips every 11 years in the solar cycle, and have seen how it impacts Earth through sunspots, solar flares, and coronal mass ejections. It's clear that our sun, our source of light, is a lot more than just a shiny object in the sky. Its mechanics and phenomena continue to captivate scientists and fuel our thirst for knowledge. If you've enjoyed this cosmic journey and want to explore more, forget to hit that like button and this video with your fellow space enthusiasts. Make sure you subscribe to our channel to stay updated with the latest discoveries and insights into the universe. Next time, we'll be deeper into the intriguing world of sunspots and how scientists predict solar activities, so stay tuned as we continue to unravel the secrets of our universe. The story of our sun is far from over. There are lots more mysteries to uncover. Until then, keep exploring.